Welcome to the calculator paper, everyone. So if we take a look, the duration of this calculator section of the paper is going to be 1 hour and 20 minutes long, and there will be 45 marks available. So the total will be 60 marks, so 45 in this paper, in this section, and a 15 on the previous non-calculator section. So we are allowed to use a calculator in this section of the exam. Scientific calculators are technically allowed, however, they are not a requirement, and even a basic simple calculator will work just fine. So we will proceed with question 1. So here we're seeing a graph with some points, and it's asking us which point is at 3, 4. So I'm just going to go up a bit here since we know the options are just A, B, C, and D. Just going to scroll up here. So 3, 4, when we're reading notation, we see that is written as X, Y. That's usually the way it's written. And so we need to follow 3 on the x-axis first. So we note here's 1, 2, and 3 on the horizontal at this point here, which I will erase. So now we're starting at 3, and then we want to go y to 4. So 1, 2, 3, 4, and we get to the point B. Okay, so the answer for this should just be, so just put a check there. Moving on to the next question. So here in question 2, we're given that 1 gallon is 4.546 liters, and we want to find out how many gallons are in 10 liters approximately. So if we know 1 gallon is approximately, so this is a wavy equal sign way of writing approximate, is 4.546 liters. And we want to find out, we want to find out 10 liters is approximately how many gallons, right? So from 4.546 to 10 liters, how do we get there using multiplication or division? What I recommend doing is seeing, okay, how do we get from 4.546 to 10, which usually involves multiplication. So a way we can figure that out, doing 10 divided by 4.546, which you can do on your calculator. So that's approximately, we can say, so to go from the top down, so from 4.546 to 10 liters, we have to multiply by 2.1997. I'm just going to use a couple of the decimal places here. And so then to do the same, right, we need to see from 1 gallon how many gallons is 10 liters. So we need to do the same to the other side. So we'll take 1 gallon, multiply it by 2. Sorry, I'll do it a bit more correctly here. 2 multiplied by 2.1997. And since we're multiplying by 1, we know that the answer is approximately, like the 10 liters is 2.1997 gallons. Equal to 10 liters. And so that's approximately 2.2. So that's the only answer. Now moving forward to the third question. We are asked, what is the mode of these numbers? So mode means the most frequent number that we see, right? So immediately as I look around, I see 125 stands out quite a bit. And I think that's the main one. So, but we have to double check and verify. So 1, 2, 3, 4. So we have 4 125s. For 125, we see 90 twice. I'm just going to note that down over here that I see 2 90s, 4 125s. I'll maybe put an S like that. Let's see, 180, there's only one of them. 155, there's 2. So from the looks of it, 125 is our answer. That is the most frequent number. Everything else occurs either 2 times or just once. Every other number, sorry. So our answer here is 125. Okay. So now moving to the next question. Sorry, there we go. So here we are given a set of numbers, and which one of the following lists is in increasing order? So increasing order means that the second number has to be bigger than the first number, and the third number has to be bigger than the second number. So it has to constantly be increasing. So firstly, be A or B, because we know that we can see here in C, we have 0.0095, and then we have 0.1 something like the rest of it. So it can't be A or B because the number that 0.95 is going to come in at some point, and it's not going to it's not going to solve it's not going to be the answer to the question. So A and B are not the answer. Now we just have to take a look and see, okay, we can see 0.1 and then 0.08. So we want 0.08 to be in the middle. So it has to be D. D has to be our answer. And we can just double check and verify. 0.0827 is greater than this, 0.0095. And then this one increases to 0.1, which is greater than 0.08, whatever at the end. So this one is in increasing order. So our answer is going to be D for this question. Moving forward to the next question, the surface area of a sphere is 4 pi r squared. A sphere has a radius r that measures 3 centimeters. So they're telling us basically that r is equal to 3 centimeters in this question. And then we have pi, which we can use 3.142 or 22 divided by 7. And we want to work out the surface area of that sphere to the nearest cubic centimeter. So not cubic centimeter, square centimeter, apologies. So we just have to plug in the values into the equation. So we have 4 here, and we're multiplying that. I'll just use a dot to represent multiplication, pi, and then we're multiplying that by r squared. We're given that r squared is 3, right? Sorry, r is equal to 3. So pi multiplied by 3 squared, which is the same as 4 multiplied by pi multiplied by 9, right? 3 squared is 3 times 3, which is 9. And then pi, we've been told to use 3.142. So I'm going to put that here. So 3.142 multiplied by 9. So for this, we would use our calculator. And we would come out to 113.112. So now to the nearest centimeter, to the nearest square centimeter, that's going to be 113. So just put the units here. And this will be centimeters. Will be centimeters squared. There we go. So now hopefully that makes a bit more sense. Again, we should always make sure we understand the units where they are in the question. But yeah, our answer should be C for this question, as that's the closest square centimeter. So moving to the next question, we're seeing a man is going to New York for work. He wants to book a hotel. The price is in dollars, and the friend says that it will actually cost more pounds than the price shown because of the exchange rate. And then the man says the opposite, that that the number of pounds will be less than the number of dollars. And then they're giving us the exchange rate. So if we take a look here, we can see, so for 1 pound, if you have 1 pound in your hand, you'll have $1.24 in the other hand. So let's say, you can even say, we can extend this further, right? In the sense that if we have 1 pound for 1.24, let's say we have 100 pounds, right? That's going to give us $124. So we have more dollars for our pounds, right? So in this case, the man would be correct, in fact, not the friend. So the man would be correct because for 1 pound is worth more than $1, right? So the number of pounds for the equivalent of getting doing the hotel booking is going to be less, right? So it's going to be a smaller number. So I'll just say here that the man is correct. And we have to explain here that the pound is worth more than the dollar. That would be a simple and correct explanation, that the pound is worth more than the dollar. For 1 pound we have, so we have less of the pounds, like the actual number, right? So if we have 100, it's less than 124, but it's worth the same amount, right? So that's a fair enough explanation for this question. Hopefully it makes sense. I noticed that some of our learners make a mistake with the explanation. So, and it's a 1 mark question. So the explanation is actually the main part of the question. So even if you answer, the man or the friend, if your explanation doesn't, isn't clear or doesn't make sense or is incorrect, then you wouldn't get the mark for this question. So just make sure that you're very clear and concise, and you should be fine. Great. So we're now in question 7. A newspaper report says that a company made $700,000 profit last year, and it says this was 12% more than the year before, and we want to work out how much profit the company made the year before. So I'm just going to show you the way to answer the question, and then I will say a common misunderstanding of the question as well, and what I notice a lot of learners do not get correct. So we have a final here 700,000, right? 700,000 pounds. And we notice that it's 12% more than the year before. So we know that the year before, let's say that the previous years, right? Previous profit, right? We don't know the exact number that is, right? We're supposed to calculate that. Let's say that's Z, right? We'll just use a letter to denote it. So we have Z over here. And then we know that if we know that it's 12% more than the year before. So we're adding 12% of Z, right? Or we're, as we would know, is multiplying it by 1.12, right? So we know Z times 1.12 or 12 plus 12% of that is going to be our profit for quote unquote last year, right? Which is 700,000. So Z is the profit from the year before. So then to solve for Z, which is the previous profit, we need to take 700,000 and divided by 1.12, right? And so doing that on a calculator would give us 625,000 pounds, right? And so that's going to be our final answer for this question. Now, what I notice the mistake that a lot of individuals make is that they think, okay, we're starting with 700,000 and we want 12% less than that. That will give us the original value. Unfortunately, that wouldn't be correct because we don't know what 700,000 is not our original value. We're not taking it. And if the question was saying, okay, we made $700,000 last year, and then this year, let's say we'll move a step forward. Okay, we made 12% less, right? Then yes, you would take 12% off, and then you'd get a different number. So I'll just show you as well what people do. So if we take 12% of 700,000, that's going to be equal to, we'll just do it on the calculator. That's 84,000. And we want to, I guess, find out the year before. So that will, normally we would assume 700,000 minus 84,000. And if we notice, we get 616,000, which is not the same as 625,000. So that's where the incorrect answer and the mistakes come in. So hopefully that makes sense. Hopefully the explanation above makes sense, that we are trying to figure out this number. What people assume is that we're starting with this number and then we are, taking 12% away, but we don't know what the original number is. The previous year's profit, right? The year before, 2 years ago, profit. So now we'll move forward to the next question. So question 8, we have income tax. We have a personal allowance, and we have a specified value here, 11,850. And then we have the formula for the amount of income tax, which is, here we can see 0.2, y minus p, and we're explained what all of those letters mean. A caterer earns $13.75 per month. How much will the income tax will she pay? How much income tax will she pay for the year? So we can see here that the income tax personal allowance is specified for a year, and initially they're giving us the value for a month. So immediately first thought is to change everything so that we're dealing with the year, because even here we say T over here is for the year, the money earned is for the year. So in order to use the formula, we want to figure out the actual salary of the caterer. So we have 12 months in a year. So we multiply 1375 multiplied by 12 to figure out the yearly salary. So 1375 multiplied by 12, that's 16,500. Right? So that's how much money they make per year. And then we want to figure out how much income tax they will pay based on that. So we want to figure out T essentially. So T here. So now we know Y, which is 16,500. We know P personal allowance is stated here as 11,850. So now we just need to plug all the numbers into the formula and we will find out what T is, or what the income tax is that they will pay for the year. So T is equal to, so 0.2. We have Y, which we found out in the first part is 16,500. And then we want to subtract P. So P is 11,850. Right, so first we have to follow BidMass. So we first do inside the parentheses. So 16,500 minus 11,850 is 0.2, 4,650. So this is essentially telling us to multiply 4,650 by 0.2, which if we do on a calculator, gives us 930 pounds. So that is our final answer for this question, 930 pounds. Again, make sure the units are there, right? And that's essentially it for this question. They just give you all the numbers and they want you to figure it out. The main thing to notice here is that the caterer earns 1375 per month. So they want you to do an extra calculation and the rest of it is just plugging it into the formula. Moving to the next question, question 9. So a worker has to set a machine to cut this shape from a piece of metal, and we want to figure out the area of this interesting shape. So immediately looking at the shape, so show you're working, and that's it. Great. So the shape immediately looks like a rectangle with a triangle on top kind of shape. So immediately my first thought would be to divide this into two, this compound shape into its two distinct shapes, right? So let's say the rectangle is A and the triangle is B. Now we want to figure out the area of A plus B. So like together the whole shape. So we first figure out the area of A and then the area of B. So if we look at the area of a rectangle, we can see here the length is 8.0 centimeters and the width is 2.5. So the area, so I'll just say A, as in for the area of the shape, is equal to 8.0 centimeters multiplied by 2.5 centimeters. So again, doing that on a calculator gives us 20 square centimeters, right? Notice, make sure the units are correct. Just so that you can keep track, right? We're multiplying 2 centimeters together. So we have 2 centimeters squared. So we have the area of the rectangle. Now we need the area of the triangle, right? Which is, so I'll just say area of triangle is 1/2 times the base times the height, right? So the base is essentially the dotted part of the line here, and then the height, I'll just draw a straight line like this, is from there to there. So we can see on the left side of the question that the height is 3.0 centimeters. So we already have H. Now we need the base. So we notice that if we look at the length, right, because it's a rectangle, so we know the 8.0 centimeters at the bottom. And if we see the dotted line along with the 2.0 plus 2.0 has to also equal 8, right? So we have here, I'll just do maybe here, 8.0 and then is equal to 2.0 plus 2.0 plus, let's say B, right? That's our base. That's what we're trying to figure out. So we want to subtract, move to the other side. 8.0 minus 2.0 minus 2.0 is equal to our base. So that's the same as, 8.0 minus 4, which is going to be 4. So our base is 4 centimeters, or well, 4.0, since we're using 1 decimal place, 4.0 centimeters. So now we have our base, we have our height, so we can figure out the area of the triangle, which is equal to B. So I'll say B here is equal to, and again, all of this working that I've done above here, I just needed to do it beside the shape so it was clear, but you should put all of that work below in this rectangle here where it says show all your working. So I'm just going to say here, B is equal to, capital B is equal to 1 over 2, right? And then the base we're multiplying here is 4.0. And then the height we're multiplying is 3.0, right? So here we can do the right side, which is essentially 4 times 3, which is equal to 12. And then we want half of 12, right? We're taking 12 and multiplying it by 1 over 2. And again, the 12, if you note the units, is going to be square centimeters, because again, we have 2 centimeters in them. So here we have 6 square centimeters. And now, as we said, we want to take, so now the area A and B, and we want to figure out the area of their sum. We want to figure out the area of both together. So A plus B is equal to 20 square centimeters plus 6 square centimeters. That's going to be 26 square centimeters. And that will be our final answer for this question. Again, the units are written here. So hopefully that makes sense. And now we'll move on to the next question, where a photographer increases the price he charges to print photographs. He wants to know if it affects his sales. Last week, before the price increase, the average number of photos ordered was 12. Okay, so we know the average was 12 before the price increase. We don't know how much he increased it. We don't care about how much he increased it specifically, right? The exact numbers. So this week we can see after the price increase, we can see, okay, this is a table saying that 26 customers ordered between 1 and 10 photos and so on and so forth. And the question asks us, does the price increase seem to have had an effect on the number of prints ordered per customer? Explain your answer, include calculations to support your decision. So we have our decision and we have our explanation. So here we're looking at average, right? If we notice in the question, we're comparing between last week and this week. We see that we have an average number of photos. So the average over here is 12. And so what we want to do is figure out the average of this week and then compare those numbers, right? So now from here, we should know that we won't be able to get an exact average, right? Because we see 26 customers ordered between 1 and 10 photos, but we don't know how many photos each one of those 26 people ordered. Like it could be 1, 2, 3, 4, all the way to 10, right? So here we get an estimate. So the idea here is to find the midpoint of all of these numbers. So the midpoint is right, we have 1 and 10, right? We want to add those numbers together, which becomes 11, and we want to divide it by 2, which again, you have a calculator, we can figure it out as 5.5. So the midpoint here is 5.5. And if we continue down in the same fashion, 11 plus 20 divided by 2 is 15.5, 25.5, 35.5, 45.5, and 55.5. Okay. So now we have the midpoint, and we want to use this midpoint to calculate the average. So we want to find the total number of, we can say total number, estimated total number of photos ordered. So we'll have 5.5 times 26, 15.5 times 14, multiplied by 6, multiplied by 4, and then these two are multiplied by 0, which is equal to 0. We don't need to do any actual use a calculator there. So if we use now we come back to 5.5 multiplied by 26. Doing that through the calculator gives us 143. Then we have 15.5 multiplied by 14, 217, and so on and so forth. Great. And now we have to add up all of these numbers to get an approximate total, right? That's going to be 655, right? So that's going to be our total number of photos ordered. And now we want to divide it by the number of customers that we have. So we have 26, 40, which is going to be 40, and we have 6 plus 4, which is 10. So then 40 plus 10 is going to be 50. So we have 50 customers this week, and they ordered a total of 655 photos, approximately, right? Sorry, not a full total. Up again, we're all, it's an estimate here. So the average, right, is going to be, again, all of this should be done in the box below. But again, just to clarify how to solve, how to understand the question, I'm just doing it above. We have so the average we have is 650. So I'll actually just do it below. So average is 655, sorry, 655, and we want to divide it by 50. So doing that on the calculator is 13.1. So we can see that this week we have 13.1 photos, average number, and last week we had 12. Even though we increased the price, we have more photos that were bought, right? And so they have to make sure that we read the question carefully. It asks, does the price increase seem to have an effect on the number of prints ordered per customer? No, it doesn't, right? Because normally when you increase the price of something, usually the number of sales drop, right? If you are all of a sudden buying milk that now costs an extra pound or 2 pounds more, you're going to have less people that buy it, or you're just, most people are not going to want to buy it anymore, right? Because it's too costly. So our answer here is going to be no. Our decision is going to be no. And we're going to say this week's average, right? Because we need to provide an explanation. This week's average is 13 photos with the price increase. And whereas last week's average is 12 photos. So the price has no effect. So the price increase, sorry, has no effect. Okay. So this is just to be very clear and answer the question. If you don't answer the question directly and correctly, but hopefully the questions. Again, making sure that we put all of our workings and showing out into the box below. So we'll move on to the next question now. So the table shows how much a garage pays its staff. We have the pay rates, where on Saturdays and Sundays we get 1 1/4 times the normal rate. So meaning we get 1.25 times more, right? Last week, a mechanic, worked 7.5 hours. She did not work on Sunday. Her normal rate of pay is 10.8 an hour, and we have to work out her total pay for last week. So first we should deal with Monday to Friday, as that's, I guess we would say, simpler. So Monday to Friday, that's 5 days. And every single day we can see they worked 7.5 hours, and they don't work on Saturdays. Sorry, they don't work on Sundays. So we will do here. So we have 10.8. So let me just say Monday to Friday. Right, so here we have 10.8, 10.80, and we want to see 7.5 hours, which is the same as 7.5. So this is for 1 day we're calculating, because they work. That gives us 81. And then we want to multiply that 81 pounds into 5 days, which gives us 405 pounds for Monday to Friday. And then now on Saturday, she earns 1.25 times her normal rate. So I'll just say Saturday, I'll just say the rate is 1.25, and we want to multiply it by 10.80. That's going to give us 13.50. Right, so now that's our new rate per hour. And on Saturday, again, we can see that she works 7.5 hours. So now we want to take 13.50 per hour, multiply that by 7.5 hours. Sorry, 1 second. That's going to give us 101.25, right? So now we want to add all those numbers up to figure out her total pay. And we get 506.25 pounds. And that's going to be our final answer. And again, we can see the units included. So 506.25. And that's our answer to this part of the question. Scrolling down, we can see that now it's asking us to use approximation to check our answer. So approximation, how would we approximate here? There's no particular way that the question specifies how, like to approximate, as long as we show some sort of approximation, a valid calculation. So we can approximate 7.5 hours, we can say is around 8 hours, and we can approximate 10.8 per hour to 11, right? So then if we do our calculations, so let's do our Monday to Friday over here. I'll just use the short form. So we have 7.5 hours, which is going to be now 8 hours. And we have 11 pounds per hour, which is now 88, right, from Monday to Friday. So we're kind of close. I mean, 80 versus 81 is a decent amount of a difference, but again, we're approximating. And then we want that over 5 days. That gives us 440 pounds. And then we have Saturday. So in this case, we would do 1.25 multiplied by 11, which is 13.75. So I'll just say the rate is 13.75 based on our approximation, or better to write it out. So 1.25 multiplied by 11, 13.75 pounds. And so now we just continue the calculation again. 13.5 multiplied by our 8 hours now equals 110. And so then adding these two together, we get 550 pounds. Which again, if you look at it, is quite a bit more than our 506.25, but again, it's an approximation, and so we were around the 500s, so that would be fine. Hopefully that makes sense and is clear. Great, now we'll move on to the next question. So here we see that a woman applies to a new job that pays 8.5 pounds a week more after tax. She will work 5 days a week and drive to work as she does in her job now. And the new job is 6 miles further from her house. And then we just have some information about her car and the petrol. So we want to see if earning 8.5 pounds more per week is enough to make it worth going to the, taking the new job. Like, is she actually going to be saving more money? Getting actually more of that money, or is she going to be spending it on the commute itself? So we can just scroll down. So now first we want to see, okay, she earns 8.5, right? And we want to see how much she's actually going to be spending just to go to the new job, right? So she drives 6 miles further from her house. So in total, she'll drive 12 miles more, right? Because she'll go to her work, which is 6 miles extra, and then go back from work, which will be another 6 miles extra. Have 12, I'll just make it clear. So 6 miles into 2, 12 miles extra per day. And then we want to multiply that by 5 because we have 5 days per week, Monday to Friday, right? It says she works 5 days a week. So per week, if we multiply that by 5, we get 60 miles per week. And since now, because we're trying to look on a weekly basis, right? Our comparison here is with a week. So she drives 60 miles extra. Now how much is that going to cost, right? For her to drive 60 miles extra. So her car travels 8.5 per liters of petrol. So we need to see how liters actually need put into her car, right? So in this part, we would do here 60, and we want to divide by 8.5. Right? Because we want to see how many liters she needs. That'll be approximately 7.7058823.5. I'll just keep it at that. And that's going to be that many liters. And how much does 7.0588 liters cost? 0.26 pounds per liter. So we need to see how much that costs. So we'll take this number. I don't want to write it out again. And it was multiplying it by 1.26. So you can just continue on the calculator from the answer that you got. And we see that it will cost us 8.894117 £6 extra per week just to commute to her work. So she's not going to actually be, making use of that extra money. It's going to be gone. She's actually going to be spending more money. So we have this I'll just say per week extra. And so if we look above, we're looking at 8.5 from before. So she's only making 8.5 more, but she's spending 8.89 more. So if we take we'll just say 8.89, we'll round this off. So if we take 8.89 subtracted by 8.50, that will give us 0.39p. So she's spending 39 pence more just to go to the new job. Just for the new job, she's actually spending more money. So she wouldn't be better off, right? So we can write here, I'll just write it outside the box. She won't be better off as she is spending 0.39 more on commute, right? So she's spending 39p more just on the fact that she's commuting, so she's not better off. Okay. So now if we go to the next question, we can see here that our boss needs us to make some travel arrangements. They'll go 4 days a week for the next 6 months. And they've specified here 26 weeks. That's how much 6 months is. He needs to arrive at 8:30 at Hull and then catch the train home at 5 p.m. every day. So we see here the tickets, trains to Hull. And then we want to see what type of ticket do we recommend from that. And then we have to explain our reasons. So first we can just do our basic calculations, right? I'll just do again some of it up here. So we take a look at the off-peak tickets. Off-peak tickets are not valid for travel between 7 and 9 or between 3 and 7 p.m. And we want to arrive at 8:30, so that definitely wouldn't be possible. And we want to catch the train home at 5, which still wouldn't be able to be used because that's between 3 and 7. So the off-peak tickets are not valid whatsoever. So we need to make note of that. So again, we want to explain our reasonings. We'll just say off-peak possible because of the timings need to look at that, and then we just want to compare the costs of all of these tickets, right? So we look at the day return, so that takes care of 1 day, and we want 4 days a week for the next 6 months. So if we do the day return, so actually I'll just do it up here. He was going to go 4 days a week. So if we take 8, multiply that by 4, that gives us 32 pounds per week, right? And then we want to multiply that by 26, right? And so we will have 26 weeks. That's going to be 832 pounds to spend if the boss decides to use the day return ticket. Now we want to look at the 1 week ticket, which nicely is calculated for us at 29.6, which we can already see is less than 32. So we know this is going to be cheaper than even the day return ticket. And we want to multiply that by 20. We want to for the next 6 months. So 29.6 multiplied by 26, that's going to give us 769.60, right? 1 year doesn't make sense either, right? Because he's not going for 1 year, so it doesn't make sense. And we can see that the costs of the 1 week and the day return are cheaper anyway, so there's no reason to take that. And then the 1 month cost, and we have months, so we multiply by 6. That will give us 682.20. Okay. So the cheapest and the most convenient option is to take the 1 month season ticket. So our recommendation here is 1 month ticket. Right. And again, all of the work that we've shown here, right? So for the weekly pricing, for the monthly pricing and the day return, we must show below. And that will be our answer to this question. So now moving forward to the next question. We can see a company has made some changes, and we want to see if these changes have made any difference to the number of days employees take off work. We can't just compare the total number of days. So if we read this third line here, this is a very important line. We can't just compare the total days as there are fewer people working in each department after the changes. So maybe some employees were let go, but we want to compare them, right? So, and then if we look at the question, so if we see the table with the information before and after, but if you look at the question below where it says, did the changes make any difference to the average number of days that employees took off sick, right? And if we, oh, never mind. So it's only in that part. So yeah, if we see we can see the word average is written in there, right? I thought it was written above too. So that should give us a clue as to how to do the question. We want to compare it by taking the averages of these numbers, right? We're trying to see if it made a difference to the average number. So for this question, we just needed to take the average number of all of these numbers. So we'll do the days before. So the days before. So the average is essentially adding all of these numbers, right? 14 plus 12 plus 11 plus 8 plus 12. Just put a plus everywhere, right? So you want to add all these numbers up. So I'm just going to add them up on the calculator. And that's going to give us, so if we take all these numbers together, that's going to give us 180. That's going to be our total, right? And then the number of employees is, we can see there's basically four columns of 5 rows. So that's essentially 20, right? We can just do a quick calculation. You can count them manually. There are 20 employees. So I'll just say number of employees is 20. So we want, if we look at the average, which is dividing these two numbers, 180 divided by 20, that will give us 9, right? So our average is 9 days before the changes. And now after the changes, we follow through in the same way. We take the average. So figuring out the total first. We get 105 by adding all these numbers. And our number of employees is equal to, so here we have 3 columns of 5 rows, so that's 15, right? 3 times 5, 15, or again, we can count it. We have 15 employees, so we lost 5 employees after the changes. And so if we take the average, that's going to be 7 days. So the average has reduced, if we note. So did changes make any difference to the average number of days that employees took off sick? Yes. Our answer would be yes here, because they ended up taking less days off after the changes were made. And again, these calculations, you would write it out a bit more descriptively. So 14 plus 12 plus 11, so on and so forth. And that will be our answer to this question. Moving on to the final question of this exam. Here, our cafe owner wants to know how many cold drinks she's likely to sell next week, and she makes a record of the sales of drinks over the last 2 weeks. She wants to use this information to see if she can predict the number of cold drinks she is likely to sell based on the temperature forecast for a particular day. So you've mentioned cold drinks twice. We're looking at cold drinks only. We don't care about the hot drinks. So this information is actually useless to us in this question. They just added it to, trick you to make sure you're able to understand the question. So use a graph paper to show clearly the data she has collected in a way that will help her do this. So essentially you want to do a scatter graph here, because you want to be able to predict, right, the temperature forecast. You want to predict. So that will essentially be like, we want to use a line of best fit, right? Hopefully that connection, you're able to make that connection. So if we look here, we want to predict the number of drinks, right? So the drinks is the main thing. That's the variable that we depend on, the dependent variable. And then we have, or the y-axis, right? That's the important variable. That's what we care about, is the number of cold drinks based on the temperature, which will be on the x-axis, on the horizontal axis, okay? So I'm gonna just do it on the graph here. I'm just gonna zoom out a little bit. So here, I'm just gonna say temperature to make sure you always label. And I'll put the units in degrees Celsius, right? That's the temperature we're working in. And then we are looking at the number of cold drinks sold. So I'll just say number of, or actually I'll just say, just undo that, number of cold drinks sold. Okay. So we can see that we start with temperatures starting at 17 and then we go all the way up to 23. Okay, that's our largest and smallest number. So I'm just going to start our x-axis here. So I'll draw the graph a bit. I'll just draw it as big as possible. And then here we can start with the temperature. So here we're starting at 17, 18, 19, 20, 21, 22, and 23. Okay. And then where does our cold drinks sold start? So we can see 24 seems to be our smallest number, and our largest number seems to be 40. So we want to make sure we go up to 40. We want to make sure we include all the values in our question. So now we want to do a scatter plot, right? So let's look at the first one, 17 and 24. Sorry, first we need to label. So from 24 to 40. So let's go to 24. How are the numbers going? Okay, they're going up by 2s and sometimes by 1s. So let's do 24, 26, 28, 30, 32, 34, 36, 38, and 40. So that should include all of our numbers, and now we should be able to plot. So 17 and 24, we have a point here. 18 and 26, right? So 18 will be, again, being the lower part. So at 18, when it was 18 degrees one day, we sold 26 drinks. 17 and 25. So 25 should be around here in the middle. 19 and 30. 20 and 32, and then 20 and 28. So 20 and 32, and then 20 and 28. So Friday, Saturday, we can see the day. Again, the day is not relevant to us, right? That's not information that we care about. We just care about the temperature and we care about the cold drinks sold. So now 19 and 27 should be in the middle here. 1929 should be in the middle there. 2235. 23 and 40. 2030 and 2034. Yep. There we go. So we've plotted all of the points, and we can see by general reasoning that as the temperature increases, people want more cold drinks. So the sale is going to increase. Now what we want to do in this question, right? So we've plotted it, right? So we've shown clearly that, that will help in a way for her to do this, so we can use the information. Now it says the weather forecast for next week, it will be 21 degrees on Monday. What can you tell the cafe owner about how many cold drinks the cafe is likely to sell on Monday? Show clearly on your graph paper how you found your answer. So here now, because we're doing a scatter graph, we always want to include a line of best fit, right? So we will include a line, and we want to make sure that half the points of the line are on one side and the other half of the points are on the other side of the line. So we can say, think about there. There seems good enough, because we have 1, 2, 3, 4, 5, 6, and we have 1, 2, 3, 4, and then two of the points are on the line itself. So this should be fine as a line of best fit. So now we have our line of best fit, and we want to predict how many drinks the cafe is likely to sell when it will be 21 degrees. Now, we didn't have a point for 21 degrees, so that's why they're asking us to predict it. And that's why we will use our line of best fit. We can see, okay, 21 degrees, if we just draw a dotted line here, we can see that we come to around, this is right between 32 and 34, give or take, right? So we can say around 33 drinks because we can't sell half a drink. So we can tell the cafe owner that they will sell. Nope. Still I'm on the line. They will sell around 33 cold drinks. Okay, and show clearly on your graph paper how you found your answer. So that helps because we exactly did that. So what I recommend is doing like a dotted line on the 21 and on, wherever it ends up on the vertical axis, right? So it's very clearly shown how we got the answer. It's very clear, right, on the line. I'll just undo that point actually, because it's not an actual point from our question. And yeah, that will be the answer to this graph question. Most people usually get a bit confused, especially with the hot drinks and the day, and they try to graph all of the information on the table, but we're only interested in two parts of the information here, being the temperature and the number of cold drinks sold, right? That's what the question says in the very first sentence. So that's a very common misunderstanding of the question. So you have to be very careful in what they say and how you understand it. It's better to take your time to understand the questions. Hopefully this helped, and this is just spare paper for the graph question above, and that is the end of the assessment. Thank you so much for watching this video. Really hope it helped, and wish you the best of luck on your functional skills maths level 2 exam. Thank you so much. Bye-bye.